Yo, so this is going to be a derivation of the trigonometric Pythagorean identities. So as you can kind of see, I have up here, I have three Pythagorean identities. They are this one, sine squared plus cosine squared equals 1, tangent squared plus 1 is equals to secant squared, cotangent squared of x plus 1 is equal to cosecant squared of x. So these are your main ones. However, in order to kind of derive these, you really just need to derive one, then you can get the rest from it. So if you don't really remember your history, Pythagorean theorem deals with sort of triangles, and it comes from this guy named Pythagoras. He discovered a special relationship between the sides of any right triangles. So if you kind of remember from a long time ago, let's just say you have a triangle here, right? And it's a right triangle. So we have this side's going to be x, the side be y, and this will be some r, right? Stands for radius, right? And just for fun, we're going to put this guy here as, let's call it theta, some angle theta, right? So one thing that you can end up doing is you can take the regular trig identities, say your sine, cosine, and tangent of a right triangle. And the one thing we actually ended up learning a while ago is something called the distance formula. And that is actually equal to x squared plus y squared is equal to r squared, right? And this actually should look familiar somewhat because it's actually the Pythagorean theorem. A squared plus b squared equals c squared, right? A squared, b squared equals c squared. Nothing's really changed except for that you just have the variables are sort of different. So if you want to, for instance, take, let's just say, let's use a different color. Let's just do black here. So if you want to do, let's take the cosine of theta, right? So here we have the cosine of theta. Put that in there for you. Cosine of theta is equal to the adjacent over the hypotenuse, right? So the adjacent side in this case happens to be x. So we're going to put x here over the hypotenuse. Hypotenuse is equal to r, right? Let's solve for x. X is equal to r cosine of theta. Cool. Keep that in a box here for a quick second. Now, since we did cosine, let's also go back and we'll go do sine. So down here, I'll go, it's the sine of theta. The sine of theta is equal to the opposite over the hypotenuse. Opposite in this case is the opposite side of theta, which happens to be y. So y over the hypotenuse. Hypotenuse is r. And we're going to do the same thing. We're going to solve for y. So y in this case is going to be equal to r sine of theta. Cool. Now, in order to kind of go, we're going to link these three. We're going to link the Pythagorean theorem and these two things here together. So here we have two variables in terms of r and theta, and then we have x and y. So really what we're going to do now is we're going to plug in your x and y into your Pythagorean theorem. Right, so let's go here. New page. All right, so remember we have your distance formula, which is x squared plus y squared equals r squared, right? Remember we have x is equal to r cosine theta. We also have y is equal to r sine of theta, right? Just kind of keep that there. Cool. So let's do the easy part. Let's go and plug it in. So we have x squared. X in this case is r cosine theta, which is going to give us r squared cosine squared theta plus y squared happens to be equal to, it's going to be r squared sine squared theta equals r squared. Now, one thing you have to notice is that there's something you have in common on both sides, and that's the r squared. So you can just divide out the r squared in this case. So cross it out, cross it out, cross it out. If we rearrange these two terms together, we get sine squared of theta plus cosine squared of theta is equal to 1. This is our first is going to be our first equation. Cool. So like I said, we just need to kind of derive one of these equations, one of these Pythagorean identities, and then we can get the rest from it. And really what we're going to do here is nothing that you haven't really done since algebra. So now that we have this, is there a way that we can kind of rearrange this or maybe manipulate it to kind of look like the others? And again, if you want to remember, the others happen to be, we have this guy. This guy's marked off, right? So this guy's done. Now we need the tangent squared of x plus 1 is equal to secant squared, and the cotangent squared of x plus 1 is equal to cosecant x squared. All right, so let's go back here. Well, what happens if we end up dividing both sides by, you know, cosine squared of x, right? Remember the one trick from algebra is you can do whatever you want to the equation as long as you do it to both sides of the equation. So let's divide both sides by cosine of x, right? Let's go to a different color here. Now you have sine squared theta is going to be plus cosine squared theta equals 1. And remember, we're going to divide it now, divide everything by cosine squared of theta. Divide that, divide that, and you're going to divide this. Cool. So it's at this point where it should kind of look almost a little interesting to you. This whole thing here should look a little interesting to you. So if you remember your really early trig identities, the one that you should have kind of learned before you kind of came and did this, you should recognize that sine squared over cosine squared happens to be equal to tangent squared. So really, we can cross this guy out, and he's left with tangent squared. Tangent squared of theta plus cosine squared of theta over cosine squared of theta. This is going to be equal to 1 plus 1. And you have a reciprocal identity here, 1 over cosine squared theta. That's going to be equal to secant squared theta. Excellent. This is your second equation. All right, we can go back. Make it out. Yep, excellent. Got that guy. All right. So last one is the cotangent squared of x plus 1 is equal to cosecant squared of x, right? All right, let's go and let's see, what do we want to do? Let's do blue again. So again, let's try and take this equation and then see if we can get it. Well, last time we ended up dividing both sides by cosine squared. Let's divide now by sine squared, see what we get, right? So now what we're going to get is we're going to get sine squared of theta plus cosine squared of theta is equal to 1. And again, we're just going to divide, but this time by sine squared. All right, so this time it's going to be by sine squared of theta. It's going to be by sine squared of theta. And again by sine squared of theta. Forgive my awful handwriting. One reason why I didn't major in English. So you kind of have to ask yourself, all right, well, what does this leave us again? Right? Something over the same thing over itself, sine squared over sine squared, and it just happens to be equal to 1. Cool. This is 1, right? 1 plus. And again, this should also kind of look familiar. This is almost just really the opposite of what this guy was. And so this happens to be equal to, so it's cosine squared of theta divided by sine squared of theta. That's going to be equal to cotangent squared of theta, right? So cotangent squared of theta. And then on the left here, you have what's called a reciprocal identity. So 1 divided by sine squared of theta is actually going to equal to your cosecant squared of theta. Cosecant squared of theta. Cool. Now you should kind of ask yourself, does this look somewhat similar to this guy? It does. You know, if you just see R1 happens to be here and our cotangent squared happens to be over there, but it's really nothing. You know, you could rearrange those terms and you're pretty solid. And that is the Pythagorean identities.